Hey everyone, welcome back. In this video, I'm going to talk about serverless technology powered by Knative and show you how you can use it to dramatically cut your costs both on-prem and in the cloud. So, as always, let's define the problem. If we're honest, we have to acknowledge that hyperscalers can be very expensive if they're not implemented correctly or optimized. You're typically paying for services that you may or may not need at certain times. And wouldn't it be great if we really could take these services and treat them more like utility, where we shut them off when they're not in use, just like our water, power, gas, that kind of thing. And that way we're really truly only paying for what we need when we need it. We have to acknowledge that we live in a very complex world that is a non-linear, decoupled, complex, non-linear world, and we really want to try to take the guesswork out of compute resourcing, because we don't really know when an application is going to be needed. Something might happen in our company where that drives a lot of traffic to the website, and so we need to be able to scale up and scale down at a moment's notice. And Amazon CEO acknowledges that they're not really seeing customers cutting costs as much as they're trying to optimize costs so that they can better weather the uncertain economy. But why wait for an economy that's uncertain? Why aren't we always trying to cut costs and save money so that we have resources for other projects? And this is where serverless really can shine. And it is a solution. It is not an end-all, be-all solution, but it's got a tremendous amount of potential, and that's what I hope to show you here today. So let's get into serverless powered by Knative. Again, we have applications with an unpredictable or bursting number of requests, especially at certain types of year. We want to build event-driven, loosely coupled systems so that an event can automatically trigger our great application to scale up or scale down. We want to use something that has a low barrier for developers, because Kubernetes, is wonderful as it is, it's got some challenges, and we want to abstract that complexity away from our developers and shield them and make it very easy for them to deploy their applications in a kind of serverless model that bursts up and down on demand, does A/B testing, canary deployments, all of that, and can really adjust for those seasonal or periodic workloads where you need more capacity at certain types of year, like Christmas and holidays, the Black Friday sales and things like that. And now, guess what? Knative can actually be used not only in just little microservices, redeploying codes, but also with container workloads. So serverless actually has kind of an interesting history that I'll just run through real quick. Probably the best known example of serverless is AWS Lambda. I used it back in my previous job for some eventing, listening for an uploaded video. Takes that video, the code runs, takes that video, runs something like FFmpeg, sizes it down by preserving the quality, and then it shuts down when it's done. That was probably the best example of serverless technology. And then in 1.5, we started using more runtimes, became sort of polyglot and portable. Then Microsoft and Red Hat jumped in, and now we have something that's called CADA, or Kubernetes event-driven type of architecture. That was really interesting. And now with version 2.0, you can handle state. You can has advanced messaging capabilities. You can blend it with your platform as a service, and it's really, really much more complete now. So what does a serverless pattern look like? Well, there's some kind of event, whether it's an incoming HTTP request or some kind of maybe webhook from Slack or Teams, or maybe your Kafka, your messaging system, that triggers an event, and Knative listens for that and does what it's supposed to, and triggers that application to kind of scale up or scale down. And there are just so many operational benefits for running that serverless pattern. and I know this from experience, you really don't know what kind of resourcing you need or how an application is going to progress over time. So you might over provision and you're paying for more than what you need. And then if you under provision, then your application is running terribly. I've seen both instances in over the years where you might lose, a customer might lose interest and say, you know what, this is just taking too long. I'm out of here. And because the application is under provision, it doesn't have the correct VM or the container isn't resourced properly. So, but wouldn't it be great if you had something with like serverless that scales up and scales down to address the customer demand when you need it, and then shuts that resource down so that it doesn't cost the company money. So enough talk. Let's get into it. Let's give an overview and show you how simple it is to take advantage of this wonderful, easy-to-use technology. Okay, so you will need a few tools to do this demo. You'll need the Knative command line interface, the OpenShift command line interface, a free Red Hat account, and then that will give you access to the OpenShift Developer Sandbox. I provided links in the description below. Okay, so let's create our first Knative service using the Knative command line tool, and we're going to do this in the Red Hat OpenShift Sandbox. So I'll run this command, and almost instantaneously, my first Knative service is created. And you can see in the terminal below that the pod is running. And yeah, that's it. Very simple command to create your service. And if I run Knative service list, you'll notice there is my service. It's already created a route for me. And I am ready to go. You saw I already accessed the app. And yeah, that's as simple as it gets for creating that first service. And if we can actually export that service to save it in a YAML file here, take a look, and we will preserve that for some kind of future deployment, either using some kind of GitOps type workflow. We can modify that behavior for scaling, health checks, all that kind of stuff. So yeah, you can use Knative to export your deployment for a future deployment through GitOps. Okay, so now notice in the topology view, the pod is turning dark blue and my pod is already terminating. So I'm going to update the service. I'm going to change the concurrency to scaling window for only 10 seconds. So I'm going to change it from the default 30 to 10 seconds. And notice too that that number iterated, I'm at 0002. So now I have a new deployment. And Knative versions those deployments. And it automatically sends all traffic to the latest version. Okay, so after 10 seconds, my app is no longer running. So I will refresh that incoming request, and now look at that. It's already running again. So it ran pretty quickly here. And you'll notice it's solid blue. So that means the deployment is running. We are confirmed there. And it's terminating already because it's already, 10 seconds. All right. Now let's do some load testing on our Quarkus deployment here. And let's list the route because we're going to export that as a variable. Okay, so I'll just export that route equals, there we go. Okay, good to go there. And I am going to use the Fortio tool, which comes with the Istio project. And we're going to run that for 20 seconds, maximum containers 10. And let's throw some traffic at it here. And notice down below here, look at that. I have got a bunch of containers, just as I told it to do. And I can do some load testing to see how responsive it is. And yeah, the testing is done. And the containers are already shutting down because they're no longer receiving traffic from the Fortio tool. We'll let those spin down. And almost done. And our pod is now at rest. thereby saving us memory and compute resources for other applications running within the cluster. No need to have them run because they're not receiving traffic. And that's the rub. That's where you're going to get the cost savings. Okay, almost done. There it is. No more pods running. Scaled to 0. Okay, so let's make another revision that is based not on concurrency, but RPS, or requests per second. So to do that, I'm going to update the revision, and I'm going to switch to RPS, requests per second, and we're going to make the scale target just 1. So let's do that. And okay, again, if you notice there in the center, in the topology view, it's now on our third iteration, our third revision, if you will. Now this is something you could probably also do using the horizontal pod scaler if you're familiar with OpenShift. And now we have basically 3 versions of the autoscaler. And Knative automatically sends all traffic to the latest version. And later we'll show you how to split that to do some kind of blue-green deployment. Okay, so now let's look at blue-green deployments. And the first thing we want to do in a blue-green deployment is send all traffic to our working version. So we're going to use the Knative tool to update that service and say send all traffic to version 3. And let's confirm that. Yep, KN revision list. Yep, all traffic is set to go to version 3, which we know is working. The developers confirmed that. And now we're going to do a green deployment. So let's make a revision that does a green deployment. And there we go. Now we have a green deployment. Let's do, let's do can revision list. And there we go. There's our green deployment. But again, all traffic still goes to the version that we know is working best. Okay, so now let's make a revision that can handle that green deployment, and there we go. So now we have 2 different versions, but again, as all traffic will still go to that first version because we were very explicit with the Knative command line tool that we still want all traffic to go to the version that we know is working best. All right, but let's now split that traffic, and we're going to send 20% of the traffic to the green version, and then 80% to the working version, so that way we can test to make sure that everything is going well before we cut over to that green version. Okay, let's list our revisions here, and there we go, confirmed. We are sending 20% to the green version, and 80% to the working version, version 3 or revision 3. So now let's do a little bit of testing. Okay, so let's just confirm. Yep, still doing 80-20. No revisions created. Look at our revision list. Yep, still 80-20, confirmed. And let's use that same 40O tool now to ensure or make sure that the load is distributed across the routes according to our specification. So yes, here we go. We're sending some load and, at the application, and 80% of it is going to version 3. 20% goes to version 20. You can see that there down below. That is exactly what we were expecting to see with that 80-20 split. So that's it. That concludes the demo of Knative. I hope you see that Knative can actually help you save a lot of money, particularly in your lower environments. If you have a development environment where you want to spin resources down when the developer isn't testing out their application, this is just a phenomenal tool to help you, cut down those costs and optimize services so that you're not using any kind of memory and compute when it's not needed. Thank you for watching. If you have any comments, please leave them in the section below. Thank you so much for watching.